Today we are discussing about database architecture, which means as we have discussed already. As we have discussed already, database is a combination of LDF and MDF, whereas LDF means, as we discussed, whereas LDF means log data file, or as a transaction log file, some people will be calling it as. MDF means metadata file. SSMS will be viewing this as a primary data file. In some cases, we also have an ability. We are also having an option to add another data file in some cases if we need some data, external data storage or something to distribute the data into multiple data files. Then we are calling it as secondary data file. It's secondary data file, it is denoted as NDF, whereas primary is denoted as MDF. Today we are going to discuss this MDF architecture. We are calling this architecture as a page architecture because the database stores data in the form of pages. Database stores data in pages. It means pages or the storage devices are not like a storage devices. Pages contains our actual data. Whereas one important point to consider here is that each page will be of 8 KB size. We will discuss in deeper about that. Our session is all about this MDF architecture or database architecture or page architecture. Whatever way we can consider in our understandable way, we can analyze the things in that way. Okay. And today, can you see my slide? Hello.
Yes, continue.
Yeah. Okay. And this is our page concept that SQL Server 8 KB page. Why we are calling it as page concept in the sense database stores data in pages. Page is actually the data as we discussed earlier with respect to SQL Server architecture. We have already discussed here that this is architecture and this is the diagrammatical representation that which we have discussed in our earlier session. Like this is a data file actually. Here, this is a data file. Here, this is a data file we have discussed already. This transaction log file is LDF and data file is MDF, that which we are calling it as now. And we are discussing about this data file. Here, actual data in our earlier session also we have discussed it in log file. The transaction log file, the log files are stored, the transactions are stored, not a log file. The transactions are stored in this transaction log file. And then from there, it will be moved to the transaction manager, accessible methods, buffer manager, and in here, log cache will store the information when it is with respect to update. Initially, the log cache will store the information and move it to the transaction log file, and from there, log file will never send the data to data disk directly. From there, transaction manager receives the data. The log manager will take care of all these things. And in our earlier session also, we have discussed that we are having a component called checkpoint to truncate the log files. And we are also having concepts like we have discussed LR lazy writer component we are having, which flushes the data from static pages to disk, and checkpoint will always internally runs, and when checkpoint comes into picture, the log file gets truncated, and the transactions will be coming into the data file after the checkpoint comes into picture. And we will also have one session regarding the checkpoint and types of checkpoints. We will discuss about this in one session. We are having one session about that also. And here dirty pages are there. Dirty pages we have discussed already in our earlier session. As discussed, uh, dirty pages are the pages that which had been not modified to the disk but contain some information. Of the dirty pages, after dirty pages flashing the data to disk, those pages will be converted to as clean page. We have discussed all these points, and in what cases these pages will be converted to as clean pages. We have discussed like lazy writer is a component which moves these dirty pages into data file or disk and uh, convert them as a clean page. In such cases, on the basis of algorithm, LRU algorithm, least recently used algorithm, and we are also having some. In what case that lazy writer comes into picture is that we have already discussed that memory pressure, or if there is any memory pressure that lazy writer comes into picture and converts these dirty pages into clean pages. And we are also having one component called PLE, that is page life expectancy. For a minimum, it means like buffer manager decides what is the page life expectancy period. And then until that, if there is no memory pressure or if there is no lazy writer, the component that comes into picture, uh, a minimum, it means like a minimum of 5 minutes for every 5 minutes. It means it might be less than 5 minutes, but Microsoft is recommending us to clean the pages for every 5 minutes. If there is, it means that page life expectancy it means like there is no memory pressure arrived in 5 minutes, and there is no lazy writer component comes into picture in 5 minutes. Uh, the PLA, page life expectancy time, will be there just like 300 seconds or 200 seconds it might be. But what Microsoft is recommending us, it should be as 300 seconds because for every 2 minutes, if this occurs for every 2 minutes or 1 minute, there might be IO issues or CPU utilization issues. Again, there will be a hierarchy, means that the performance will be impacted again. Just a recap we are discussing now about our previous session. That's it. And in our previous session, we have also discussed about all these points like three types of protocols like that which we use in our SQL Server, and CMD parser, query optimizer, which generates optimal plans, ACID properties like atomicity, consistency, isolation, and durability. Buffer manager uses these kind of components like MTL, memory to live, plan cache, log cache, dirty pages, page life expectancy, least recently used algorithm, memory pressure, soft passing, hard passing, write ahead logging, log manager, and log manager. I think you are aware of all these topics that which we have discussed in our early session, and now we are discussing about this data file, which we are calling it as MDF and database architecture or page concept, because in this data file, uh, the data is stored in pages. It means like where we are writing, how we are writing our class notes or our theoretical notes. When we write on a notes in the page, just like this, in the same way SQL Server writes in a page. But we have to remember one important point is that we will end our writing at the end of the page, or some people will write 17 lines, 18 lines, or 20 lines, or 30 lines in a page, depending upon their writing skills. But here we have to understand one point here is that every database contains only 8 KB of size. Okay, and we'll go into this data page or page like architecture page concept we are discussing about today. Okay, actually this is hierarchy of a page where we have already discussed, and we will be discussing about the system databases in our next session. User databases are databases which are created by user. Okay, and every database contains data file and log file. We have discussed log file in the sense LDF. Sorry, log file in the sense LDF and data file in the sense MDF. Here we are calling it as extent, a file group, and something. Uh, Log file is also the extent page, page extent heap or file group we are calling. It means like a 8 KB size is called page, and 8 pages. It means like I'll show you once. One 8 KB size is we are referring it as page, and then 8 pages means 8 into 8 KB equal to 64 KB. Here we are referring it as extent. Sorry. And 8 extents means like into 64 KB is referred to as file. And file will be referring as file group again. It's a hierarchy, just the hierarchy we are discussing here. Nothing more than that, nothing complicated, just to understand. We will not use this options in our daily database activities or in our daily, in our production servers. Rarely we will be using, but just to have a knowledge on this and for interview purpose, we are discussing about all these concepts. And these 8 files will be referred to as file group again. What we have to consider here is that we consider page extent file file group database. Group in the sense we'll be having a primary file group, multiple file groups we can create again. 8 extents is referring as we are referring 8 extents. 8 extents we are referring it as one file, and as we discussed, we are referring it as 8 pages. Now, like one page is 8 KB, extent is 64 KB, and file is 64 into 8 KB. And again, one file group is 64 into 8 into 8 KB again. It means like these are file groups, and we cannot define the database size. It may grow depending upon the. You can also, we should not consider this file group size as this. Just consider this file size 8 extents, 8 pages as one extent, 8 extents as one file. That's, and We'll be discussing about this architecture now. Here we are seeing data file extent file group, and in Oracle we'll be calling these file groups as table spaces, and extents as blocks will be called. See, and we are having two types of extents in our SQL server. One is uniform extent and another is mixed extent. Mixed extent as uniform extent, it means like we can see here. Here we are having a table called sample. It means an extent which stores only the sample tables information is called as uniform extent. See here, table one, table one, table one, table one, table one. 8 pages means like this is one page. 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 These 8 pages information in one extent should be referring to only one table. That type of extent we are calling it as uniform extent. If an extent contains a multiple tables information, not only table, we can consider one store procedure, one index or something. Any other way we can consider not only table. We should not consider only not only table. Any other storage. It means like not like a store. Any other store procedure, or you can see indexes. Likewise. Mixed extent in the sense if there is any, see here, table 2 index 1 index 2 table 2 table 3 index 3, it may contain multiple indexes number indexes data, or multiple tables data, or single table data. It means like a mingling manner, not only one table related information, but it may contain a single table related information, or multiple tables information, or multiple table and index, or index and table, or only multiple indexes, or only multiple tables. Whatever may it can store, it contains information like this. If it is a uniform extent, it should contain a data pertaining relating to only single table or single index or single sort procedure in that. And what we have to we should consider here as a page definition, in the sense, actually, a page is nothing but a 8 KB size of information, nothing more than that. 8 KB size, we are calling it as a page, nothing more than that. And we have to discuss 3 points here. Nothing more we can discuss about a page definition, and we will move on to, sorry. Let it be. We are having multiple types of pages in SQL Server, but we will be considering about some pages. The important pages that which we'll be discussing now are, here we are having types of pages like data page, index page, sort page, camp page, scam page, IAM page, PFS page, boot page, server configuration page, file header page, BCM, we'll be calling bulk change map as BCM, TS, DCM as differential chain map. These are all the types of pages. Not only these types of pages we will be having in SQL, we're having more types of pages then. But we're discussing only these types of pages. Means like the important pages we can discuss here. Before that, we'll be seeing this page architecture actually. Before going into that, this is a page architecture. This page, the total page size is 8 KB here. See here, this is a header, and this is a header. It means like This is row offset we are saying. It means this is a body of page. Actually, this is the data where this is the part where data is stored. Row 1, row offset. It means like if the row 3 adds, here row 3 will come. Every page will store 96 bytes of data. 96 bytes of memory is reserved to a page header, which contains metadata. It means like what the page is having the information in it. What the page is having. It means like what is present in the page. To store this information, 96 bytes of memory is reserved. And here, how many rows are there? 812 bytes of data here we are storing. It means like 8 KB, 8 into 1024 bytes minus 96 here. And for every row offset, to store this row offset address or something here, this is referring to this row 1 and this is referring to this row 2. If there is any row 3, this is referring to here row 3. To store this row allocated information for every row, we can this 2 bytes of data. 2 bytes of data here. For each and every row contains 2 bytes of data. Here we should consider here as a page header which contains the metadata of the page, and this is the actual data where the page is stored or the body of the page, and this is a row offset where this row, all this row information is stored, and row 1 and row 2, row 3, row 4. To store this row information, row 1, what kind of information that it means like not what kind of information, which row address will be stored here, which is referring to this row 1, row 2, row 3, likewise row offset until row n. For every row, it takes 2 bytes of data. Types of pages that which we are having, the most important types of pages that which we are having in SQL Server and database. Discuss this is a page where our actual data is stored. Means like here we can see that what he's saying, data about actually how the data is stored inside the database files, and it contains the cluster index leaf level information also. Index page while discussing about indexes, we will be coming to know what is an index, why we will be using index, just to understand here. To improve the performance of a query, we will be creating indexes on a table on a single column or multiple columns to improve the efficiency or improve the performance of a query. And here we are having sort page. Sort page in the sense mostly this is used by TempDB. It means like what some people will be querying, like select star from EMP, order by ENO. In that case, what TempDB will be doing is that it will be creating some temporary tables by sorting the data, by ordering the data with respect to ENO column, either by descending or by ascending, whatever the way which we are uh, applying our query to retrieve the data. Uh, the temporary storage information here in the sort page, the temporary storage information is stored in the sort page. This is most probably it is used by TempDB only, not all other databases. And here we are saying GAM page. GAM page in the sense what we can GAM in the sense global allocation map. SGAM page is a shared global allocation map. GAM page records what extents have been allocated for any use. It means like it might be of any use, not like a single extent or uniform extent or not like that. Whereas SGAM pages records what extents are currently being used as a mixed extent and also have one unused page. There is what we can say is that GAM page allocates the information of a uniform extent. Simply, we can consider as GAM shows the information of multiple. It means like a mixed extent. IAM page means index allocation map page, which contains information of all the pages. It means like what boot page contains, what server configuration page contains, bulk chain map page contains, file header page contains, GAM page contains, sort page contains, index page contains. All these pages information will be stored in this IAM page. All contains all the pages information, we can say. PFS means page free space. Here we are saying that the 8 KB size, we are referring it as page. It means whenever we open this page, PFS, what kind of information this PFS stores is that in page 1, how much free space, in page 2, how much free space, how much used space. It stores all the information. All this information will be stored in this PFS. And the boot page, this is the heart of SQL server, we should say, because boot page is stored in master database. It contains all the information related to our database. If the boot page, we have to consider one important point we have to discuss here. The boot page gets corrupted, our SQL server will not come online again. It means like it contains the booting information complete. The boot up information is stored in this boot page. It also contains the checkpoint details, backup details, LSN details, database properties inside the page log file. And if there is any scenario that log file was corrupted, that information also we can see in boot page here. And we have to consider another important point here is that only one boot page will be available per database. If there is any user database or any database, only one boot page we will have. We will have only one boot page for one database. It all, and this is a server configuration page. It means like sp underscore configure. We'll be considering sp underscore configure, enable CRL, show advanced options, 0, enable, disable, reconfigure. These configuration details will be stored in this configuration page, server configuration page. This is also this page also will be available in master database. File header page, it means like here we have seen a file header page. This is a file header page header which contains the page information, metadata, and bulk change map. Bulk change map, in a sense, what we have to consider is if there are any bulk transactions, bulk logged transactions, or bulk logged operations, it means like huge amount of operation or huge amount of transactions are coming into the database. Then this bulk change map, those kind of transactions will be stored in this type of pages. Means like it records the extents that have been modified by bulk logged operations or bulk logged transactions. Can hold up to 4 GB of data maximum. It means the bulk transactions will be stored in this type of pages. Differential change map means like you will understand this type of page after all backups, because differential change map means there are any transactions that are coming into the database after the differential backup has been taken. The modified transactions, it means contains the extent information modified after. Not this is wrong actually. This is differential backup and this is bulk transaction. Don't get confused here. I'll modify this slide before sending to you. Differential change map contains extent information modified after differential backup, and bulk change map contains extent information modified after bulk transaction since the last backup. It might be full backup or differential backup or any backup. Full backup or differential backup. If there are any bulk transactions of since the last backup, those type of information or extents will be stored in bulk change map. Differential change map, in the sense there are any transactions extents that are modified after the differential backup. Those changes are stored in this differential change map page. And we have to consider here is that here we should consider some kind of pages here to query about page or something. If you want to query about any kind of page and to retrieve how much amount of space that has been occupied by the page, or to retrieve any kind of information about page or file ID or something, we have to enable one trace flag called dbcc trace on 3604 to retrieve the information about any kind of page. And we will see practically what it is and what kind of how can we see the page, or how the data is stored in the form of pages, and where the data is stored actually. Till now we have discussed that it is a physical, where page is nothing but a physical physical component where our actual data is stored. Each page is given a unique number called page number. We have to discuss here. Each page is given a unique number called page number. each unique number, each unique page is called given a page number here. We have to discuss this also. This point is also important here. We have to consider, and you can also see the page or page information. See here, I have created a database called data file and a table in that database. See, I think this was not connected. For a while, we'll be connecting it. Okay, right now. Sorry. It is not coming. Yes. Okay. Here we are in this. Where is our database? Database. Okay. Here we're having a table called pages. To see this information or pages information of this database, we are having a command called dbcc show file stats. I think so. We had written here, I think. Something dbcc commands. See, file ID 1 in the sense it is metadata file or MDF. File group 1, it is saying total extents, it is having 128 extents. And used extents, it is showing 43 extents. Name, data file, location of this data file, it is showing. And we can also see what kind of pages are there, and what is the page header, row offset, row address. We can also see all this kind of information related to pages. If you want to see that, we should enable this trace flag dbcc trace on 3604. Sorry. Brackets we have to. This is a trace on. This is a trace flag which we have to execute before retrieving the page information. Nothing more than that. Nothing is new here. And if you want to discuss about, we are also having some. We have discussed dbcc db info. We are also having one command call to retrieve the information about pages. dbcc db info. See here. See here, database version created 852 and database create version, database version 852, database create version is 852 again. It means like whenever we upgrade a database and we are not aware, it means like we have upgraded our database from 2012 to 2014. In that case, we can see here, we can come here and see saying that database version is 852, create version is 852. This is a create version. If there is any database upgraded, this version will change. Means like from 2012 to 2014, again this version will change. In that case, we can observe, we can consider here as this is the create version and this is the upgrade version. But here, as we have not upgraded the database, it is showing both the versions as 852. The complete database information we can see here. Entry 1. See, we will see scan 1, scan 2, completion. Actually, we are not having some amount of data in this database. It will also show, means like see here, oldest backup LSN, differential base guide, DB mirror ID, and you can see all this information. If we insert some more 100 rows of data, we can also see here row offset information and all the details we can see. In the log file architecture, we will also see again what the dbcc log file and what the information will be stored there. We will be seeing we'll see all the information there also. And today also we'll discuss in detail. See, I'm trying to retrieve the pages information of this table actually. See here, pages -1. Here 0 is referring it as here 0 we are referring it as current database, or we can also write our database name. Both the information will be same. Pages, in the sense we are retrieving the pages information, nothing more than that we are writing here. Or we can also retrieve here, we can also write if not we can also write the table name. It means like what kind of information page the table contains. Here hyphen 1 means some amount of data, 2 means more amount of data, and 3 means uh, some more amount of data. That's it. It's just a trace flag we are enabling here. See here, DVCC execution completed successfully. Sorry, should retrieve some kind of information. Nothing. Then 30 is retrieving. I think so. We are doing some mistake. Let's see once. Wait, we'll see. Means like we'll use again this command. DVCC means database consistency check, nothing more than that. DVCC page as it is saying. DVCC IND data file is our database name. Pages is our table name in the data file, and this should give our information actually. Why it is not? We'll see once. We have executed this trace flag, right? Should retrieve the information actually. I'll do one thing. Create table. We did not insert any data. That's why it's not showing anything. I think so. We will insert some data in this table, and we will see like 1 comma. We'll insert one page, and we'll insert multiple pages by saying go at a time. Some hundreds of rows. Insert, yeah, inserted. Say go 100. Change this. 100 rows we have inserted. Let us see now it will show any information. Yes, actually this command should retrieve the information about this pages table. See here, this page file ID is 1 metadata file. It is saying data file, and this is page ID. IAM means index allocation map file ID. 1 index allocation map page ID is showing null. And this information is stored in this information is stored. See here, page ID is 314, and index allocation map page ID is 314. It means that this IAM page contains this page information. It is saying this is object ID, and this is partition ID, and page type. Page type 10 means index allocation map. Page type 1 means this is a data page. index level. If we create any index here, it will be enabled as 1, if not so 0. And the next page ID, previous page ID, and previous page ID. We have to consider. Actually, when we have executed this earlier, we are not having any kind of information in this table. That's the reason why it did not show anything. That's it. We see two, it gives some more detailed information about this page, nothing more than that it will show. Sorry, it should retrieve date. Okay. As the indexes were not created, it is not retrieving any kind of information. We will see execute 3 and see. Think so. It is for non-cluster indexes. I think it will not show. It will also not show. Yes, there is any index, it will show. Not, it will not show the detailed information about that page. Nothing more than that. Here we have to consider, and another important point that we should consider here is dbcc login for db info 0. If we say 0 here, this is our current database information. Instead of writing our database, oh, instead of writing our database name here, dbccind, so here, instead of writing our database name here, we are saying 0. It means it takes a current database, nothing more than that. And we have discussed all the points here: page ID, page file ID, and what we have to discuss again, nothing more than that. We have to discuss here. Yes, that's all about the page and the page architecture and the types of pages that which we have discussed. We will be having some queries to retrieve the data information about a clean page or we can also see how much amount of data. It means like how many clean pages are there, how many used pages are there in our database. We can also see. Think we'll just select this command. No need of using this lengthy command also. Showing the log file session. Here we are having. Execute this and see. Will it show or not? Trial session. Clean pages, dirty pages. Yes, we are having. It's like what we will do is we'll insert some more rows of information items so that it may retrieve some amount of information. Set. See here, the clean pages are 1 and dirty pages are 5. What I will do here is now dirty pages, in the sense we have discussed that the pages that has been that had been not modified to the disk. The clean pages in the sense the pages that are modified to the disk. Schema is dbo object name user object type user table. It is saying, means not like a store procedure or anything. What I will do is that I will show you now these dirty pages will be 0 again if we run the same query after running this checkpoint. See, we have discussed already that what checkpoint will do is that it will clean the pages. See here, no dirty page, no clean pages. See. Again, if I insert some rows, see here. Again, if I insert some rows here, sorry, this common. If I insert some 100 rows, again, if I execute this query, now see, again it will show one dirty page and 4 clean pages it is saying. If I run checkpoint again, it will not show dirty page again. See dirty page. This is all what about our page concept, and the summary or hierarchy that we have discussed till now is that what is a page, types of pages, architecture where the header is reserving some 96 bytes of memory, and the row where the actual data is stored, and the row offset for every row allocation it requires 2 bytes of memory, and the trace flag which we should enable is tbcc trace 01, and the script to count clean pages and dirty pages. And we have also shown here already discussed here this trace flag should be enabled, and this is a command to see how many pages are there and what are the pages, types of pages, file id. Likewise, if the file id, see here, if the file id is 2, fid is 2 means, see here, previously we got only 1 or 2 rows. See how many rows we are getting now, because multiple. See page id 314, this IAM page. This IAM page is containing 314 page information. Here also, here also, here also, here also. The same as we have inserted some multiple rows to see this clean page and dirty pages. We are seeing this. These many page file ID. Here page file ID is 2 means that is log file. We have to understand nothing more than the LDA. Hope we have discussed more. And is there anything to discuss, Abhi? Hello.
Bro. No.
Stop the recording.
Okay.